In algebra today, we did lesson 15, and I know like some teachers are on a different pace. Maybe they're not there yet with that lesson, or maybe they're not teaching that lesson and they're doing something else to supplement it. Lesson 15 was about the irrational solutions of quadratics. So there's two ways we classify numbers. Well, there's probably even more ways, but the main one is rational versus irrational. And most numbers are rational. So think like anything that can be represented as a fraction or a ratio, it's kind of in the name, rational. Anything that can be represented as a fraction, like for example, whole numbers, you can write them as a fraction if you put them over 1, are considered rational, including their decimals. So like 1/3 is 0.3 repeating. It's a decimal that goes on forever, but it has a specific pattern, so it's considered rational. If the number is irrational, that would be a decimal that goes on forever without repeating. So like a classic example is the number pi, which is 3.14, and I don't know the rest. But it goes on forever without any like certain pattern. So that includes numbers like pi or non-perfect squares, which we'll do some examples of those, but you will see that in this unit, non-perfect squares, and they won't necessarily say square root of 24 in your answer. You'll have to simplify them. So that 9th graders tend to not know how to do, so I'll review that. Also, even upperclassmen kind of struggle with that. Why? I don't know. To me, it's like one of my favorite things to teach. I think it makes so much sense if you do like the factor tree method. There is another method, but I just don't like it. It doesn't make sense to me. So I go with the tried and true method, which is to make a factor tree. So I'm going to probably do that on a separate screen. But the purpose is to understand what it means by radical symbol and plus or minus symbols. So I'm going to go to a different, more blank slide. And we will simplify some non-perfect squares. So let's do 32. All right, trying to think of numbers that have a lot of factors in them. Okay, so these are all examples of non-perfect squares because when you try to square root them in the calculator, you get a decimal. And of course, the calculator will round that decimal because it can't show you an infinite amount of numbers. But these all go on forever without repeating. So that's what we mean by irrational, probably a non-perfect square. How do you simplify them? You need to make a factor tree, break it down into its prime factors. You need two numbers that multiply to 32, other than 1 and 32, 4 and 8. Okay, 4 and 8. Both are not prime, so you have to break them down further. What does 4 break into? 2. Those are both prime because they just break that down into 1 in itself, right? Now we need to break down that 8. What does 8 break into? 4. And 4. Okay. And then 4 again breaks into 2 and 2. So only look at my prime numbers, the ones at the ends of our branches. I'll even cross out the non-prime numbers so you don't get confused. I want you to think of the square root symbol, also called a radical symbol, as a little jail. It even looks like one. To escape the jail, you need a partner. So we're looking for pairs of the same number. So I have like a pair of 2s here. I have another pair of 2s here. For each pair, you write it once. And because they escaped, they go outside. If you have multiple, then multiplies. So 2 pairs of 2s, write it once per pair. We'll multiply that in the next step. And then any leftover prime numbers don't get to escape. They don't have a partner. They will be written like this too, underneath the jail, the black radical symbol. All right, what's 2 times 2? 4. So the equivalent of the square root of 32 is 4 radical 2. Also, something we talked about today was that anytime you square root, what do you have? Anytime you square root, you have a plus or minus, okay? Except for 0. 0 is like the exception because it can't be positive or negative. Now, when you are doing your square roots, even if it's a non-perfect square, you're going to simplify it and then put the plus or minus there still. So let's try another. Give me 2 numbers that multiply to 20. 4 and 5. And there are others. You can pick whatever you want. If you do it right, you should have the same prime numbers at the end. So 5 is prime, 4 is not. What does 4 break it to? 2. And we are looking for just prime numbers. Maybe cross out the others. If they're broken down further, they're not prime. And envision the little jail cell. For this one, what number needs to go on the outside? And just 1, 2, I have 1 pair of 2s to write it once per pair. And you leftover prime numbers go under the radical. So this one is the same as 2 radical 5. Yes. Because we are simplifying. In your answers, you will not see square root of 20, like say with multiple choice. You'll see 2 radical 5. The reason we write it on the outside is because we had a pair of the same number. So like things like when you square something, you times it by itself. So when we're square rooting, this can escape because it's that times itself. Make sense? Yes, no? Yeah. Okay. So if you have a partner, you get to escape the gift. Don't advance anything. Okay. Okay, last one for this activity. What multiplies to 24? 64. 6 is not prime, break it down further. Those are both prime. Now check for 4. 4 brings it to 2. Okay, don't look at the non-prime numbers, ignore them. Between these, do I have any pairs of the same number? Yes. I have 1 pair of 2s, no other pairs, so just the 2 will go out here. And I have 2 leftovers without a pair. They do not get to escape. If there is multiple numbers inside or outside, you multiply them. Okay, so what's 3 times 2? 6. So this one is equivalent to 2 radical 6. All right, make sense? Yeah. What happens if you have no numbers left over? It's not. Well, okay, now that you bring that up, that's kind of a good question. Numbers like 17 that are prime already, we can't simplify the radical. We'll just leave it like that. But what I meant was if you have a factor tree, so maybe you forget that 64 is a perfect square and you go through this process to break it down to prime numbers. You'll see that when you do that and you start looking for your pairs, crossing out my non-prime numbers, don't look at those. But when you start looking for your pairs, you'll notice that I have 3 pairs of 2s and no leftover prime numbers. That's because 64 was a perfect square. If you were trying to do this, you'd end up with nothing under the radical, which would just like go away. And then it'd be 2 times 2 times 2, which is 8. That's square root of 64. So if you forget about a perfect square, and you do this, and there's nothing left over, but it was already okay, so that's really it. And then just reminding you that, I'll come back to this, but when you are problem solving, you're isolating the variable. So you always like start with what's farther from it, undo what's being done, It's just now sometimes you might also have to like simplify the radical. And then if there's a plus or minus in your answer, which you should every time you square root, then there's two solutions. If you square root 0, there's one solution. There's no plus or minus. Also, you cannot square root a negative. So if you see that, that would be your no solution. Questions? Comments? Okay. So then the practice is lesson 15. I will leave it on this slide because it's often people really looking at it, so I'll leave it on that side. But lesson 15 is what we are doing today for the mastery score. You make sure that's at 80% or higher before you do other things, whatever that is. Number 6 on today's is the one that we are looking at right now. It says find exact solutions, meaning no decimal rounding. We don't want any rounded decimals. Well, I mean, approximate solutions would be your rounded decimals. But exact solutions would be with the radical symbol. So notice they already have the plus or minus and radical there. So you just need to put it in the correct spot. And it wants you to do it by completing the square. So we'll do it that way. What's the first step in completing the square? No. Okay, good. So completing the square, it has to be in this format. What do I need to do to this to make it where the C is on the other side of the equal sign? Good. That's first step in completing the square. The second step, do you guys remember it? One half of the, and then you're going to square it, and then you will add to both sides. That's a test question, by the way. Maybe you recognize it from the quiz too, because I modeled it after the test. But so we rewrote it. I'm kind of condensing my work because I don't have a lot of room. What's my B value here? So I'm going to take half of -4. What's half of -4? We're going to square it. What's -2 squared? And then we're going to add that to both sides to make a perfect square on the left side. So it becomes x squared minus 4x plus 4. Whatever you do to one side, you do to the other. What's 11 plus 4? 15. Step 3 is to factor that perfect square trinomial. So what multiplies to 4 and adds to -4? And it should be that because we want it to be condensed, like we want to be able to write it like this. Stop. Stop. Like, honestly, so annoying. Just be quiet. All right, moving on. Factor it. And then the last step is to isolate x. So that means undo what's being done. Opposite of squaring is. And then opposite of subtracting 2 is. And I do need to simplify that radical. Also remember that there is a plus or minus there. And I'll do the simplifying off to the side. What multiplies to 15? So really no duplicates, no pairs of numbers. So really it's just going to be plus or minus square root of 15. And it looks like the way that they have it written, it's 2 in front. Because this one's completely blank, like no plus or minus in front of this. Then it's plus or minus square root 15 goes in that blank. And now for your approximate solutions, you put that in the calculator. So let me do that in a different one. So I have 2 plus the square root of 15, like break it up, the plus or minus, and then 2 minus the square root of 15. So those are your 2 decimal approximations. Let me see where it wants you to round to, because that would make a difference. It says a thousandths place. So how many decimal spots is that? 3. So find like 3 spots after the decimal, look to the right of that. That'll tell you if where you underline stays the same or if you round up. So is it going to be 5.872 or 3? 3. Good. To the right is a 9, so it's closer to 3 than the 2. And then the other one is negative 1.87, and is that going to be a 2 or a 3? These are my decimal approximations. So not my exact answer. These are my x-intercepts rounded. Questions on that? All right, questions on others? 5. Okay. So 5. Okay, so find the exact solutions, again, by completing the square. So what is step 1 in completing the square? Okay, good. So remember, you can only do completing the square at this level when A is 1. So then we want to move the C value to the other side. How do I cancel it here? And whatever you do on one side. So this cancels. This is how I'm going to just have it rewritten for now. Step 2 is where you take half of B, square it, then add to both sides. So don't tell me, just wait. But basically you want to make it to where when I do go to my step 3 and I factor, so we have our B value here, we want the same number here and here, and we want it to add to 10. So what number does that have to be? I'm looking for the same number here and here that add to 10. Incorrect. Same number here and here that add to 10. 5 and 5, good. So in other words, half of B, you guys with me? So in other words, half of B, that's why that's the step. Square it, because when you square this, that's what gives you the number on top. And you multiply these 2 numbers, right? That's the whole point, why we do half of B, square it, then add to both sides. So what I'm adding to both sides is 25. Where you do one side and you do to the other. So then my left side becomes this, which really, like, I just factored that. Right? What multiplies 25 and adds to 10? 5 and 5. But whatever you do to one side, you have to do to the other. What's negative 8 plus 25? And then my left side will become this. So x plus 5 in parentheses squared. We want it to be that way so that it's like way easier to simplify than having the 2 separate x's. Opposite of squaring is whatever you do to one side. I get x plus 5 plus or minus the square root of 17. 17 is prime, so like I can't simplify that radical. What's opposite of adding 5? Whatever you do on one side. And while you could really just write it like this, the way it wants you to type in your answer has the negative 5 first. And I know that because they have the plus or minus on the second part. So sorry, my screen froze. Okay, now I caught up. Okay, but it was negative 5 here, 17 there, Now my approximate solutions, I go to Desmos for, or really any calculator to give you the approximate values. Okay, so it was -5 plus or minus square root of 17. Then -5 plus the square root of 17. And 5 plus the square root of, oh, oops, -5, that's my bad, and I needed to put the minus here. Okay, yes. No, you cannot combine these. These are not like terms. Kind of treat it like it's the radical symbol, kind of treat it like a variable. You cannot combine them. But good question. So here's my decimal approximations. We want it to the thousandths place. So look for your third decimal spot, look to the right. It's going to be -0.877 or 6. 7, because to the right of that place is an 8, so round up. Next one, it is, wait till I ask. So is it going to be 1, 2, 3 or 1, 2, 2? Based on what's to the right then. Or I should have said that. So is it 0.123 or 0.124? Okay, good. So it either stays the same or it rounds up 1 depending on what's to the right of it. Questions on this process? Maria, did you have a question? Yeah. Number 1. Okay. Okay, so solving each using plus or minus notation. So just isolating x, always undo what's being done. So what is opposite of squaring something? So whatever you do to one side, you do to the other. What's the square root of 144? 12. And they already have the plus or minus there for you, but you, when you normally solve, just have to remember. The 12 will go there. For here, what's opposite of squaring something? Whatever you do on one side. And like I said before, you can use the calculator to reduce that for you and give you the correct fraction fully simplified. But since these are both perfect squares, it's pretty easy. What's the square root of 25? Square root 4. So that's going to be my square root of that fraction. Square root for numerator and denominator. Good on that one. Yeah, no problem. We may have time for one more, depending on how long it is. 4, okay. Okay, so explain the difference between the square root of 9 and the solutions to x squared equals 9. So, let me see. Okay, well, it's definitely not the second one. Because we know that when we've been solving, you have to square root both sides, and that's why there's 2 values that make it true. I'm going to say that it's this one, and it is. Because you know how when you put it in your calculator, square root of 9, it only tells you 3. It doesn't tell you plus or minus 3. I don't know what sort of like math theorem it is that says it's this and not that. But the calculator will only tell you that one. But we know that solutions are values that make x true. And there's 2 that do that. 3 and negative. Okay, questions on this one? I think that's all we have time for. Should you have questions on anything else though ever, Unit 7 related, primarily, then make sure that you ask during this hour, or maybe in future.